Welcome back to your chemistry classmate. Now we shall continue few more expected models for the coming entrance examinations. So apart from that, find the correct order of rate of Friedel-Crafts alkylation. So rate of Friedel-Crafts alkylation asked. So here if you observe the options CH3, Cl, CH3, Br, CH3, F, CH3I means methyl group is common, fluorine, chlorine, bromine. So you know the basic reaction of the Friedel-Crafts alkylation. You know alkyl group can be added to the benzene molecule by electrophilic aromatic substitution is called as Friedel-Crafts alkylation reaction. You know that this is the basic reaction, benzene plus RX group in the presence of anhydrous AlCl3, it forms R with means R group attached to the benzene and HX is the byproduct. Now this is the basic reaction. Now based on this tested. So which will increases the rate. In which case Friedel-Crafts reaction happens very more. So if you observe that, the one mechanism step in this, CH3 is the common, you can take X. If it is react with the AlCl3. Now in between these two, what happened? One coordination covalent bond will be formed because it contains 3 lone pair of electrons. One pair of electrons gives to here. So what happened here? CH3 slowly bond is breaking, slowly bond is making AlCl3. Finally what happened? This bond will be break CH3 plus remaining AlCl3 X minus. Is it clear? Suppose if it is if X is Cl, then it is AlCl4 minus. Is it clear? Now in these two, first step, this is the step 1, this is step 2. Which step is the rate determining step? You know, this is the rate determining step. This is not rate determining step. In this step, formation of the coordination covalent bond happens in the case of fluorine, bromine, iodine and chlorine. In which case it is more? In which case this X size is less, that ready to give the pair of electrons quickly. Hence CH3F is giving a pair of electrons quickly, then it is forming the it is helpful to form the Friedel-Crafts alkylation very quickly. So hence CH3F, then after that CH3Cl, then CH3Br, then CH3I. Generally based on the living group we are thinking, as per that we will get the first option, but that is not the correct. So here you have to consider this is the rate determining step as per that. So second option is correct. Is it clear? Now look at the next question. So this is an important model. In the NEET point of view, generally they were not asked this type of questions, but the mains point of view very important. But anyhow, it is a very simple important model. An optically pure organic compound has a specific rotation of plus 40 degrees. So specific rotation, generally we know that alpha equal to 40 degrees. The optically purity of sample that exhibits specific rotation of 32. That means some alpha sample given and some alpha pure compound given, pure compound equal to plus 32. Is it okay? So some alpha sample given, alpha pure compound given. In this time they are asking the optical purity. So as per this, one smallest formula is there, that is E equal to E nothing but here enantiomeric excess equal to alpha sample by alpha of pure compound, okay, into 100. So alpha sample how much given in this? How much given? So the optically pure organic compound specific rotation, this is pure, 40 is pure. So sample how much given? 32. That is what we get here, 32 by 40 into 100. So if you simply will get 80%. So hence our option is 80%. So here I shall give a small explanation. You know, in the optical compounds, suppose just assume 100% some organic compound, 100% organic compound. Here two possibilities are there. What are that? If R configuration, S configuration equal, then that is called as a mesomeric form, a racemic mixture. we can say the racemic mixture. This is racemic. If R form and S form not equal, then this is called as enantiomeric excess, E. Remember that. So 100% organic compound. If R form S form equal, then that is racemic mixture. Generally 50% 50%. If both are not equal, then that is called as enantiomeric excess. That means in that remaining content, R form is more or S form is more. For example, in this, see, we got 80%. That meaning is what here? This is 80%. That means remaining here, racemic mixture forms only 20%. Now in this, in the total organic compound, suppose if R equal to 80%, from here what you get here? 10% R, 10% S. Then what is the total R form? So total R form in this compound equal to 80 plus 10. You get 90%. So this is the one of the important way to identify the R form, S form very clearly. So apart from that, they asked, but here very simple formula. Remember that R sample by R pure compound. That is the formula to find the enantiomeric excess. Is it clear? Okay. Now look at the next question. This is also important model. Already a very simple. You know that what is aromatic, what is non-aromatic. We can identify very easily. So the following compound, one compound given here is aromatic, anti-aromatic and non-aromatic. So you know that for aromatic, what are the rules you are supposed to follow? First of all, it is the ring structure. So it must have the conjugation and it must be follow the Huckel's rule, 4n plus 2 into pi electrons. So first of all, it is see the ring structure. It has planarity. So alternatively, so observe that alternatively, that means conjugation is there or not. So irrespective of the bridge, of course here oxygen present in the at the bridged form, so over the two rings, but is it affect the conjugative system? Does not affect. So conjugation is there and it has two rings and it is following the 4n plus 2 into pi electrons also. Because of what reason? Here 1 2 3 4 5 5 double bonds, so 5 pi bonds, that means 10. So if you substitute here 2 rings, 4 into 2, so 8 plus 2, so pi, it is also satisfied. So it is a ring structure, it has a conjugation or it has resonance, and it is following the Huckel rule, 4n plus 2 pi electrons, hence it is aromatic. Is it clear? Now look at the next question. This is also one of the important model. So here one structure given, cyclohexene, KMnO4 NaOH cold. So whenever you observe this reagent, it is Bayer's reagent. So in the Bayer's reagent, if you observe the reaction, steps, what are the steps involving here? Just look at here. So this is the reactant they were given, KMnO4. So generally potassium permanganate, it is in the purple color. Finally it converted into the MnO2, that is colorless. Because of that reason, it is helpful to identify the saturation and unsaturation in the organic compounds, especially in the alkenes and alkynes. So KMnO4, K plus plus MnO4 minus. Is it okay? Now MnO4 minus, how it is reacted, just observe the mechanism. Mn, now 2 oxygen here, 1 more oxygen, and O minus, and here 1 more oxygen. So this is the structure of Mn4. Now here what happened in between these two, these pi electrons are moving here, these electrons moving here, and these electrons are creating here, attached there. So then what happens in the first step? So this is the step happens. Both are attached at oxygen, here also one oxygen, Mn, and here it is O minus present as it is, and this is O. This is a transition state. This is 5-membered cyclic transition state. So this is also pericyclic, we can say pericyclic also. That means the groups are attaching at the same side. So after this, if you add NaOH, that means NaOH already available. What happened here? So both are converting into, this is one OH and this is one OH. So both are same side, same plane. So remaining come out as MnO2. MnO2, it is colorless. So here what happened? Dihydroxylation happens. Dihydroxylation. So finally, what is our correct option here? The correct option is C. So generally, if you observe, the first one is the bond present as it is, this is wrong, and in this case one is like this towards you, one is backside. It is also wrong because as per this pericyclic reaction, it is attaching to the same side. So hence our option is this one. Is it clear? Now look at the next question. A compound analysis gave the following result. C equal to 54.54%, H equal to 9.09%, and vapor density of the compound is 88. The molecular formula of the compound is, so it is very clear, it is empirical formula concept. Okay, now as per the empirical formula concept, steps are involving, but here one important point is carbon and hydrogen percentages. If you count it, you will not get, it is not equal to 100. It is not equal to 100%. That is why what we should do, first add these two and subtract from 100. So what we get here, if you add those two, 54.54, 9.09. If you add, what you get here, 63.63. So if you subtract from 100, 100 minus 63.63, what you get, nearly 36.37. So this is oxygen. Remember that. Is it clear? So these two percentages not 100. That is why if you add these two and subtract from 100, and you get the 36.37%. This is the oxygen percentage. Now here three atoms are there. So carbon percentage how much given? 54.54 by its atomic weight 12. Similarly, hydrogen, how much it is? 9.09. What is its atomic weight? 1. Oxygen 36.37 by 16. So if you simplify, what you get here? Just to check it, 4.53. This is 9.09. If you simplify here, it is nearly 2.27 times, it will be cancelled. After that, divide with the least number. These three values divide with least number. Here, which is the least number? 2.27. That is why by 2.27 by 2.27 by 2.27. So how many times it is? 1 time. How many times? Nearly it is 4 times. How many times it is? 2 times. So hence, what is the empirical formula? C2H4O. This is the empirical formula. Is it clear? Now, empirical formula got. What is the empirical formula got here? Is it clear? If you have doubt, once again you check it. This is the empirical formula. So C2H4O. What is the empirical formula weight? So 2 into 12 plus 4 plus 16. What will get total? 44. Empirical formula weight you got 44. Now here observe that molecular formula weight we required. Molecular formula weight not given, molecular formula weight indirectly given, vapor density. That means molecular formula weight equal to 2 into vapor density. This is the formula. So 2 into 88. So 2 into 88, what get here? 176. Now we require the n factor. Why we required n factor here? Because molecular formula equal to n into empirical formula. This is the relation between molecular formula and empirical formula. So here n factor nothing but molecular formula weight by empirical formula weight. So what you get here? Molecular formula weight is 176. Empirical formula weight is 44. Nearly how many times? It will be 4 times. So if you substitute here, then what will you get? So this is the empirical formula already we got. So molecular formula equal to 4 into C2H4O. Then what will you get here? C8H16 and O4. C8H16O4. Then what is our option? B. Is it clear? So this model many times they are asked. It is very important. And in this question, the specialty is Oxygen percentage not given, and molecular formula weight indirectly given in the form of vapor density. Is it okay? Now look at the next question. In CONH3 6 times Cl3, the number of covalent bonds. You need to identify the number of covalent bonds. So first of all, what is the structure? You know, CONH3 6 times Cl3. First of all, it is ionic. It is converting into CONH3 6 times. This is positive and Cl minus negative. So 3 chlorines are there. So this is in this compound ionic species are there, but that is not required here. Covalent. So what is the structure of this? What are the molecules present in the inside of the coordination sphere? So CO is the central metal atom. You know, 6 coordinate covalent bonds with respect to ammonia. So this is the structure with nitrogen. Each nitrogen contains one lone pair of electron, but at the same time each nitrogen contains 3 hydrogens. Observe here, 3 hydrogens. 3 hydrogens. This is also 3 hydrogens. Here also 3 hydrogens. Here also 3 hydrogens. Here also 3 hydrogens. Observe here, nitrogen with hydrogen, there is a covalent bond because electrons sharing takes place. Nitrogen to cobalt, it is a coordinate covalent bond, and the coordination pair to chlorine ionic bond. So here in this compound all types of bonds are present. Sometimes they ask that kind of questions also. So all kind of bonds are present in among the following. So coordination compound, it we identify very easily. Now in this we identify only covalent bonds. How many covalent bonds are there? Nitrogen with hydrogen only covalent bonds. So each nitrogen contains here 3 covalent bonds. Like that, how many are there? 6 nitrogens with 6 into 3, 18 hydrogens are. So total how many covalent bonds will get? 18 covalent bonds. Is it clear? Now look at the next question. This is also one of the important model. For which of the following molecules significant mu not equal to 0? That means dipole moment not equal to 0. So if you observe the first molecule, benzene ring, chlorine and chlorine. So if you observe here, benzene ring, this is carbon, chlorine, this is carbon, chlorine. So carbon to chlorine dipole moment works. Is it okay? Here also carbon to chlorine dipole moment works. So equally works. That means here definitely mu equal to 0. How much dipole moment works? That side, topward, same downward from carbon to chlorine, because compared to the carbon, chlorine is the more electronegative. Similarly, Cn. So if you take the structure like this, Cn, because it is a planar structure. So C triple bond N, C triple bond N. Here also almost how much working in this way? Same working in this way. That is why here also mu equal to 0. If you observe the next C, so what is the structural observation? Observe here. This is the structure of OH. Observe here. Sometimes this H may be present in this way or sometimes in this way, or sometimes downward one side, upward one side. So definitely based on the arrangement of the structure, dipole moment exactly not equal to 0. So definitely something will be exist. So definitely here mu not equal to 0. In the case of thiols also same reason. Is it clear? You take the OH one side in this way, otherwise opposite. So in that context definitely, so one time what we can take in this way, OH, OH. Based on the arrangement, definitely the dipole moment does not work equally on both sides. Definitely there is a difference. Hence mu not equal to 0. Similarly in the case of thiols also. That is why in the case of these two, C and D, mu not equal to 0. Is it clear? I hope we get the clarity of all these questions. Then once again we will meet in the next class with a few more expected models. Thank you.